We're back with Winston, and now we have both an x and a y variable for Winston's position. So now we can make Winston hop up and down, have a little Winston party, woo! Very nice. Let's review what this code does before we keep going. We have these x and y variables at the top that store the center position of Winston's face, which we use in this line here when we make the ellipse for his face. Then we position the eyes and the mouth relative to the center of the face. So we subtract or add to x and y in order to make sure that the eyes are 50 pixels away and 100 pixels away. For example, the mouth is 50 pixels to the right of the center of the face and 40 pixels below the center of the face. So let's go through and see what else we could store as variables. To do that, I'm going to go through each line of code and look for what we call hard-coded numbers. Those are numbers that are just straight numbers, not variables or dependent on variables. Let's see. In our first ellipse call here, we have 300 and 300 for the width and height. So we can make a variable for these instead, like face size. So face size equals 300, and then we can pass face size in here, and right now it would pass 300 as the value. Cool. Now let's keep going. Everything in here is using x or y or eye size, but here for the mouth, we once again have 150 and 150 for the width and height. So we can make a mouth size variable. Say mouth size equals 150, and we'll go past mouth size here. And it'll just pass in 150 right now because that's what the variable is equal to. Okay, so now that we've done that, we can just easily change the face size here, and we could easily change the mouth size, like that, and we can change the eye size again. Okay, so that's cool. But there's something I don't really like about that, and that's, when I change the face size, I actually want that everything else changes relative to the face size. So if I make the face size really small like this, I want his eyes and his mouth to be really small too. If I make the face size, half of its original size, the eyes and the mouth should also be half of their size. Because otherwise he just looks really silly because his eyes and his mouth are way too big for his face. They're not even connected anymore. So what we want to do is somehow make these variables, mouth size and eye size, be dependent on this variable, face size. So let's bring it back to what it was. So the way we can do this is we can make these values be based off the face size value. So we can say mouth size equals face size over 2. So we're using a fraction of the face. We're saying take 1/2 of the face size. And if you're not familiar with the fractions, there's tons of videos on Khan Academy that you can use to review how fractions works. All right, now for eye size, it's around face size divided by 4. It's not perfect, but it's pretty good. Oh, 7. There we go. That's better. See, if you get the fraction wrong at first, you can always fix it later. Just fiddle with that number until something makes sense. Okay, so now if we resize the face again, see how the eyes and the mouth are actually resizing along with it? It's pretty cool. But there's still something wrong. The eyes and the mouth are still going off the face when we go really small. The sizes are correct. The problem is the offset from the face. And what's happening here is that down here, when we position the ellipses, we have x minus 50 and y minus 50, and then x plus 100, y minus 60. So even if our face size is only 50 pixels, we're still having the eye positioned at minus 50 pixels to the center, which is going to make it off the face. So we need for 50 and 100 and all these numbers here, all of these should also be fractions of the face size, so that when the face size changes, the amount that the eyes are offset and the mouth are offset, those numbers should also change. All right, so to show you what I mean, let's do the first eye. X minus 50. So x minus 50 pixels. This means it should be 50 pixels to the left of the center of the face. Well, what we actually want now is to use the fraction. So it's going to be face size divided by 6. So 1/6 the size of the face. Cool. And then 50 will be also face size over 6. So now, if we resize, notice how that eye is perfectly positioned. Good eye, Winston. Good eye. The other eye still needs some help, though. So 100, that'll be face size over 3. So 1/3 the size of the face. And 60 is 1/5 the size of the face. So face size over 5. Great. Let's resize it. Very nice. We just still have a problem with our mouth. So we'll go down to the mouth. This one's maybe face size over 6 again. And this one's about face size over 7. All right. Now everything is done proportionally. Let's check it out. Woo! Now we can make Winston really small, and his eyes and mouth are still inside his face. I'm sure Winston's really happy about that. All right, yay. So let's review what we're doing here. So at the top, we have our variables, and we start off with a variable that's just storing a number, 200. But then we make our mouth size and eye size variables be dependent on that number as fractions of that number, so that if face size is currently 200, then mouth size will be 100. But if we change face size to 300, then mouth size would suddenly be 150, so that it's always changing in proportion. Then down here, when we calculate our offsets, we're also using fractions because we want the offsets to also be changing proportional to the face size. We basically just want to make it so that we have this one variable that affects everything. And we can do that with variables and variable expressions. So, now that we understand how to make variables dependent on the values of other variables, we can do way more with our programs. Let's celebrate by making Winston huge. Go, Winston. Come on, keep going. Keep going. Never stop. Keep going. Yeah.